This is a smaller version of the permanent magnet acrylic or acrylic permanent magnet statorless motor. And as I've explained before, and I'll explain again, the permanent magnet points north because magnets are compasses. And it has a considerable amount of torque making it point north. Approximately 2 millinewton meters. That's like 2 gram force, maybe a little less. So that's very little, but it's considerably a lot if you look at how much force it takes to push it. And I have measured it with a piece of 3x5 card and then pressed the card on a scale, on a jeweler's scale, and actually measured 2 grams for the same amount of a bend. Now you can see it turns freely on the armature. The acrylic armature turns freely. There's nothing connecting the acrylic armature. Look, I can take that right out of the bearing. There's nothing connecting that acrylic armature to anything. It's just hanging from a fishing swivel, and there's a piece of wood with a hole in the bottom that the axle goes through. So if I turn it on, it runs by being controlled from a TV remote, and it has an infrared sensor on the bottom. It uses a 9-volt battery, and to get it started, you see it's running out of phase. So it's not running very well right now. But if I give it a little push, you'll see it will run in phase and it will run much better. Now I'm going to try and get it going a little faster. I don't think it's going to run much faster than that without going out of phase. Now, what will make it go out of phase is the friction from the bearings. So if this was in free fall without any bearings, it would run as fast as the motor could turn it. So that's doing somewhere maybe near 120 RPM, maybe a little faster, maybe a little slower. So let me show you what happens if I stop the armature, and the motor will just turn the magnet around. And there won't even be any counter rotation because the magnet pulls on one side and pushes on the other side, so it doesn't it won't make this spin around in a circle. Well, here it'll go a little bit just from the weight of the magnet. But to get it going, you got to make it go slow and give it a little turn. And you can see it's not perfectly balanced. And I had hoped to use it for other purposes. I tried making a boat out of it. And it has another servo on the bottom that I call the kicker servo. And that would extend the weight out at the same position in each rotation, activated by a light dependent resistor. So when that extended out, it would move the center of gravity, or the center of mass of the armature, and it would push a little. And in theory, that would make a boat go. But it doesn't work too well. So I like it as a statorless motor. And I'm going to go back to making this same model with these kind of big magnets. These are 3/4 inch N52 neodymium magnets. I'm going to try and make these kind of magnets on a boat so the boat will spin a little faster in the water. The boat only spins about, I don't know, maybe 5 or 10 RPM in the water, if that much. And this will make it go faster with the bigger magnets. So that's my aim. So give me a like, subscribe, rumble. Stay tuned, and I appreciate subscribers. I really do like subscribers. I'm trying to get over that 1,000 mark, and I'm only up to like 220 now. So anybody who subscribes, I'll subscribe back to you. If you put a comment, I'll subscribe back to you. So thanks for watching again. Stay tuned.